So here's a question. Given that the sine of x is equal to the cosine of 3 pi over 11, and that x lies in the second quadrant, determine the measure of angle x. All right. I'm going to remind you about some things that we talked about on Friday. When we're talking about the cofunction identities, we said the following, that the sine of pi over 2 minus, let's say x, since this is in terms of x, is equal to the cosine of x, that the cosine of pi over 2 minus x is equal to minus the sine of x. Now remember, sorry, plus x. If you're in the second, this is actually I should be saying it this way, and I'm using pi over 2 plus x. Sorry, I just made a mistake on that because it said something about the second quadrant, right? So if we're looking for a second quadrant angle, then it means that we're talking about pi over 2 plus x. If that doesn't make sense, then you need to be watching that video that I did a couple of months ago on YouTube. Okay, like I said, I didn't tape the one from Friday, but there was one that was there from before, and I'm urging you to watch that if you didn't catch up with what we did on Friday. But this is one of the things that we talked about. If there's a first quadrant, then it would be a slightly different thing. But for the second quadrant, this is what we said, that the cosine of pi over 2 minus x is equal to the sine, sorry, the cosine of pi over 2 plus x equal to minus sine x. The sine of pi over 2 plus x is equal to the cosine of x. Okay, so that would mean that instead of saying the cosine of x, let me come back to what this is saying up here now. Instead of saying the cosine of x, instead of saying the cosine of 3 pi over 11, right, I could actually make that into the sine of pi over 2 plus 3 pi over 11. Let me make sure that that makes sense to everybody, right? We're talking about a second quadrant angle here. So it would suggest that if this statement here that I'm underlining now, I'll underline it in red, is true, right? If the cosine of x is the same thing as the sine of pi over 2 plus of x, then I could say that the cosine of, this is my x, this is really what my x is here, this 3 pi over 11 is really my x, is equal to the sine of pi over 2 plus 3 pi over 11. That's what the cofunction identity says. So let me just check in to make sure that that first statement makes sense to everybody. Okay? Janaya, does that first statement make sense to you? How about Janaya on that one? Travis, thank you. Janaya, how about you? Does that make sense? Yes, that was the one from Friday. So all I'm doing is, yeah, good. So what I just wrote down makes sense then, that the cosine of 3 pi over 11 is equal to the sine of pi over 2 plus 3 pi over 11. Does that part make sense as well? Correct, correct. Okay, so let's just keep this going here. So that means that the cosine, let me go back to black actually. That means that the cosine of 3 pi over 11 is equal to the sine of, now let me get a common denominator here. And that common denominator would probably be 22. So that would be 2 into 22 is 11 pi plus 6 pi. Right, so just making sure everybody follows what I just said. 2 into 22 is 11. 11 times pi is 11 pi. 11 to 22 is 2. 2 times 3 is 6. So that's 6 pi. Okay, so that means that that's equal to the sine of, that looks like 17 pi over 22. So the cosine of 3 pi over 11 is equal to the sine of 17 pi over 22. Well, here's something else that we said. We also said that the sine of x was equal to this thing here, right? So that means that this, the sine of x, which is what we said the sine of 3 pi over 11 was, is equal to the sine of 17 pi over 22, So if that is the case, then what does x equal then? What is the value of x if that is the case? The sine of x is the same thing as the sine of 17 pi over 22. So what's x then? 17 pi over 22, exactly. Right? Which we can confirm, or you should confirm for yourself, is a second quadrant angle, right? It's more than a half pi, but it's less than 1 pi. 17 pi over 22 makes sense, all right? And one of the things that you could do just to justify that is to go back and check, find what the cosine of 3 pi over 11 is, and see if that's the same as the sine of the 17 pi over 22, because the two things that if you work them out, should actually be the same. Okay? All right, so that's the first thing that uses that cofunction identity that we talked about. Let's try this other one. Solve this equation for c, right? So the sine of 4c minus pi over 4 is equal to the cosine of 2c plus pi over 4. So again, we have this situation where on one side of the equation you have sine, on the other side of the equation you have cosine. Okay, they want an answer between 0 and pi over 2, which means I'm in which quadrant am I talking about then? If I'm talking about between 0 and pi over 2, is that quadrant 1, 2, 3, or 4? Jeremiah says 1. What do other people think? Is that quadrant 1, 2, 3, or 4? Come on, folks. I need some more response here. Harish says 1 as well. All right. What do other people think? Yeah, good, good. Okay, some of the same people that I normally get answers from are answering me. Okay, so Emily, Harish, and Jeremiah, yes, it is in fact quadrant 1. So what I can do is I can use one of the two cofunctions that we talked about. We can either say that the sine of pi over 2 minus, let's say in this case, c, is equal to the cosine of c, or we can use the other one, the cosine of pi over 2 minus c is equal to the sine of c. So either one actually would help us in this case. So here's what we have on one side, that the sine of this thing is equal to the cosine of that thing. It truly doesn't matter which side you decide to rewrite. For no particular reason, I'm going to go ahead and rewrite the left side. No particular reason. I could rewrite the right side as well, but I'm going to rewrite the left side. Instead of saying the sine of 4c minus pi over 4, I'm going to say that the sine, according to what this, I'm going to underline it here, according to what this line here says, that the sine of 4, let me go back to black, 4c minus pi over 4 is exactly equal to, if I go what this underline thing says here, the cosine of pi over 2 minus the c, which is, all of this is 4c minus pi over 4. Okay, so the sine of this thing, so this whole thing here that I'm circling, that's like my x. That whole thing is my x. So the sine of this is equal to the cosine of pi over 2 minus that same x. The whole thing is my x. So that means that that is equal to the cosine of, let me take the bracket away now. So pi over 2 minus 4c plus pi over 4. All right, I'm minusing both of these things. So it means that I should be adding those two things together. Okay? So therefore, that is equal to, let's see now, the cosine of, I'm going to put my like terms together. A half plus a quarter, well, everybody hopefully knows that that's the same thing as 3/4. So 3/4 of pi, half a pi and a quarter pi added together, minus 4c. Okay, so the sine, the original thing that we had, the sine of 4c minus pi over 4 is the same thing as cosine of 3 pi over 4 minus 4c. This, remember, we said, according to the question, this sine of 4c is equal to the cosine of this. I'm going to set those two things equal to each other now. So this cosine of 3 pi over 4 minus 4c is exactly equal to this other side over here, which is the cosine of 2c plus pi over 4. Okay. Have I lost anybody? Have I left anybody behind? I need to know, right? Because I can go over and do that all again. Neil and Riddy, how about you? Are Neil and Riddy still following me on that? Does that make sense, Neil? Does that make sense, Riddy? Start with Neil. Neil, I'm just calling you out here. You there? You understand? And Riddy, how about you? Does that make sense so far? Where's Riddy? Where is Riddy? Did you just move the pi over 4 to the other side? Okay, let me answer that question in a minute. Where's Riddy? Oh, there you are, Riddy. Okay, could you go over? Okay, I sure can. I sure can. So step two, and you mean by step two, you're talking about this step right here, I'm assuming. Travis, right here? Okay, so here's what I had. Okay, first of all, let me make sure we're clear. This thing says that the sine of, let me point to it here. The sine of C is the same as the cosine of pi over 2 minus that C. So I therefore said the sine of this whole thing is my C. All right, maybe I shouldn't have used C. This whole thing here is my C, right? So, or my x then, if you want to call it that way. And that's equal to the cosine of, according to this thing, pi over 2 minus that whole thing. So I'm minusing the 4c minus pi over 4, which means if I'm minusing all of this, that minus is applied to both things in the bracket. So I'm minusing 4c and I'm adding the pi over 4 because you're minusing a minus. Okay, Travis, does that part make sense so far? Travis, you follow that? Okay. So all I've done now is I said that this is what I have, and what I need to do now is just put my like terms together. These two pi terms, this is pi over 2, this is plus pi over 4. You can confirm for yourself that adding them together gives me a half plus a quarter is 3/4. Okay? Then minus the 4c. And then all of this sine c from the beginning, sine of this thing here, which I'm calling my c, the sine of was equal to the cosine of 2c over pi over 4. So I'm just setting this thing that we just got and setting it equal to the cosine of 2c plus pi over 4. Right? That's what this thing said. That all of this that we rewrote as a cosine is now equal to this other cosine on the other side. Okay? Really, does that help out a bit? Makes sense. Okay, really, how about you? Does that are you now more clear on that? What I just said? Ready? Okay. So what do you think I'm going to do? What do you think I'm going to say next? What do you think is the next logical thing for us to say at this point? Anybody? The cosine of the left side is equal to the cosine of the right side. What do you think happens next? Anybody? Not just Riddy, not just Travis, but what do you think I'm going to say next? Take away the two cosines. Thank you, Noah. So really what I'm going to say is that the 3 pi over 4 minus 4c is equal to the 2c plus pi over 4. Okay? And then what I'm going to do is I'm going to collect my c's on one side. So I'm going to say 2c plus 4c is equal to 3 pi over 4 minus pi over 4. Okay? I'm just simply switching the pi over 4 to the left, switching the minus 4c to the right. So on this side, I'm going to have 6c. And on this side, I'm going to have, again, pi over 2. I'm hoping that that makes sense. 3 over 4 minus 1 over 4 is 2 over 4 pi over 2, in other words. Okay? Does anybody know what the answer is at this point? What's c equal to? Anybody think they know what c is equal to without me actually putting it down? 3 pi? No, no, that's not correct. That's not correct at all. That is not correct. Anybody have a different answer to Jeremy? Pi over 12. Well done, Noah. Because what I'm doing is I'm multiplying both sides by 1 over 6, or if you like, dividing both sides by 6. So this side, the pi over 2, is being also multiplied by 1 over 6. Does that make sense, Jeremy? Yeah, okay, good. So pi over 12 would be the correct answer. So that's how I would solve that. Yes. So that's the end of that question. And that's kind of a way of me reminding you, multiplied, yes, reminding you how this thing works. By the way, 6c times 1 over 6, same thing as just dividing this side by 6. That works out to be the same thing. All right, so everybody clear on that? That hopefully makes sense, everybody. Odd and even functions are functions that have certain properties. the sine function actually is an odd function, right? And if you look at the graph of a sine function, which you're looking at right now, you've seen sine functions before. They have this wave-like pattern to them. They go down, they go up, they go down, they go up. And one of the things about the odd functions is that they have what's called rotational symmetry or point symmetry. So if I put a pin right here in the function, in fact, I'll mark it at the origin, and I were to rotate it through 180 degrees, this part would come up down here, and that part is going to go up here, and you're not going to know that I did anything to the function. Another important property of odd functions is the following. The sine of minus x is equal to minus the sine of x. So in general, for odd functions, if I took the f of minus x, if it's an odd function, then it's equal to minus the f of x, right? And you'll see in a minute why I chose to go over odd functions with you. Even functions such as the cosine function, here's a graph of the cosine function. This does not have rotational symmetry. If I put a pin here and did a rotation, this would not look the same after I were to turn it through 180 degrees. So the other kind of symmetry that these functions have is line symmetry. So if I were to drop a line down along the y-axis, so that line, I don't know why that line doesn't look like a line, is a line of symmetry, and this makes just cuts this function in half, and the left side and the right side actually look the same. The important point I wanted to make about cosine functions, which are even functions, is this quality. That the cosine of minus x is actually equal to the cosine of x. And that's, in fact, one of the characteristics, algebraic characteristics of an even function. Putting a minus into the function just gives you back the original function. Putting a minus into an odd function gives you the negative of that function. Okay, simple point, but it's going to have bearing on what we're going to be doing for today. We're looking at something called the compound angle formulas. So I'm going to start off by giving you one of those formulas. You don't have to memorize it. I'm just telling you what it is. There is a proof of it. And if anybody wants to come back in and you're not required to be able to prove it, but if anybody wants to go through it with me, come see me in the 3 to 3:30, and we'll spend some time going through it if that's something you want to do. But I will give you this compound angle formula, which says that the sine of a sum of two angles is equal to the sine of one of those angles times the cosine of the other angle plus the cosine of the first angle times the sine of the second angle. That's just one of the trig, what's called identities. I'm going to talk more about trig identities later on in today's class. But that's just a trig identity. So could we use that identity to derive, I'm going to go back to black, to see if we could derive the sine of x minus y? Well, one way that, so in other words, this is a sum compound angle. This is a difference compound angle. So if I have a difference, not x plus y, but x minus y, could I use this compound angle identity to come up with this? Well, I'm going to show you now for the first time how these identities work. So this says the sine of x. Instead of saying x minus y, I said x plus minus y, which means that it's the same thing as x minus y, but I'm just using plus minus y. So it looks like a sum instead of a difference. So I'm going to follow what this is saying. It says the sine of x, I'm going to write down the sine of x times the cosine, I'm looking again at what this says, of minus y, plus the cosine of x times the sine of minus y. All I'm doing is I'm just following what the identity says. This is my x, this is my minus y. So according to this, the sine of x times the cosine of y, in this case it's minus y, plus the cosine of x times the sine of the minus y. Again, just following this exactly as it says. Now here's where what I just taught you is going to come in handy. The cosine of minus y is just simply the cosine of y, because cosine is an even function, so it doesn't change anything when you put a minus y into the function. Still cosine of y. Now, the sine of minus y though, so this is plus the cosine of x. The sine of minus y though becomes the minus the sine of y. Okay, right? That's what happens when you take the sine, which is an odd function, of a minus. It becomes a minus of that function. So I can rewrite this as sine of x dot cos of y. The product of these two, one is positive, one is negative, means I can put minus the cos of x dot the sine of y. Okay, again, this is simply the compound angle formula for the difference between two angles. The sine of x minus y is equal to this sine x cos y minus cos x sine y. But if it was sine of x plus y, it would be sine x cos y plus cos x sine y. Again, you will be given this formula. You won't have to derive it. But I showed you that you could derive the difference formula instead. Let's try that also for again, you're going to be given this, right? You don't have to memorize it. You're going to be given that. Let's now try cos of x plus y. This is the compound angle. So the one we had before was the compound angle for sine, which is sine cos plus cos sine. The compound angle for cos is cos cos minus sine sine. So let's try using the difference, try to come up with the difference formula if we had the cos of x minus y to represent the cos of x minus y. So instead of saying minus y, I'm saying plus minus y. It's the same thing. So I'm going to follow what this says up here. So that's going to be the cos of x dot the cos of minus y minus the sine of x dot the sine of minus y. All right, just following what the formula says. That's all I'm doing, just following the formula. Okay, so this one here, remember, is just going to be the cos of x dot the cos of y, because cos, putting a minus into it doesn't change it at all, minus the sine of x. Remember, sine of minus y is going to be the same thing as times the minus sine of y. Right? That's what an odd function does when you put a minus into it. So the first part of this is just simply cos x dot cos y. This is a minus times the minus, this becomes plus sine x dot sine y. Okay? So all these things are what we call compound angle identities. That's all they are. And I'm showing you how you can use them if you are going from a plus to a minus. The third page of this is how can we use it to come up with what's called a double angle formula. What if I was trying to find the cosine of 2x or the sine of 2x? Well, one way I could do that is I could say, and remember, this is from the previous page, right? That's if you go back to the previous page and have a look, this cos x plus y is equal to cos x cos y minus sine. That's exactly what this page said. Cos x plus y is equal to cos x cos y minus sine x sine y. It's exactly the same thing. But now I'm going to see if I can use that to come up with a double angle, what's called a double angle formula. I'll write that on the side, double angle formula. Double angle identity. Okay, so cos of 2x. One way to think of the cos of 2x is think of it as being the cos of x plus x. X plus x is 2x, right? That's simple algebra. So, but separating it like that now allows me to use this way of writing it out. So if this is right, this cos of x plus y is same as cos of x plus x, then I can write that as the cos of x dot the cos of x again. Actually, I'm going to put the whole thing down a little bit to give me some more room. Right? So cos of x, since they're both x's, it's cos of x minus the sine of x dot the sine of x again. Because there's no x and y. It's all x's. It's all x's. Okay. So, does anybody remember from grade 11, if I took a cos x times a cos x, what is that cute way that we refer to it in trigonometry when I multiply two causes together? Does anybody remember that from grade 11? Hopefully you remember this from grade 11. Cos x times cos x is the same thing as, the same thing is going to apply here. Sine x times sine x is sine squared x. That's what it's referred to as. You don't say sine x squared, but that's something completely different, right? In fact, let me just make a note of that. Cos squared x means what we said it meant. It meant cos x times cos x. That's what cos squared x means. Some people make the mistake of putting this, cos of x squared. And that's not the same thing. That's just completely not the same thing. They're not equal at all. So please don't make that mistake. I'm going to erase all of this now. Actually, you know what? Let me stop this because I know that sometimes when I do that, the computer goes haywire. So let me try it this way instead. So that's just something that if you're learning it for the first time, that's fine. But the fact is that that's what it is. Cos x times cos x means that you're taking the cos of x and multiplying it by itself. And the way that we say that in math is to say cos squared x. Okay. Let's try that now for sine. So sine of x plus x is the same thing as the sine of 2x. So that means applying this formula to that. Oh, geez, things just went off the rails. Oh, no, maybe not. Yeah, that means that if I apply that to this up here, it's going to be the sine of x times the cos of x. They're both x's. There's no x and y here. Plus the cos of x times the sine of x. So it's not x and y, it's just x and x. So this says sine x cos x. This says cos x sine x. Can this be, why isn't the x squared? Okay, Kristen, thank you for the question. I'm going to get back to you on that. I promise I will. Let's just try to simplify this first. Can this be simplified? It says sine x cos x plus cos x sine x. Are there any like terms here at all? Or is it that's the end of it? Was anybody see any like terms here? It says sine x cos x and it says cos x sine x. It's referred to as a commutative law in math, that the order in which you multiply some things doesn't matter. Same thing for addition. The order in which you add things doesn't matter. So addition and multiplication are both commutative. Subtraction and division are not commutative because the order in which you subtract does matter. The order in which you divide does matter. So you're right. These are actually like terms. So really, because they're like terms, I can write this as 2 sine x dot cos x. Okay? All right. I'm going to pause for a bit because I want to address Kristen's question. So I'm going to add a page. Right? So this is not what was planned originally. And I'm going to make a distinction. Now, get your calculators out, please. And I'm going to talk a little bit about the difference between cos squared x and cos x squared. Big difference. Big difference. Now, I will say this. Another way that you could write this is to say cos of x all squared. Now, these two are equal, right? Those two things are the same, but we don't normally write it like that, right? Not to say that this thing I just wrote down isn't the same as this thing over here. They are, but the way that we sort of make sure that people don't confuse the two of them is to write the squared on the cos, because it does mean that you're talking about this. Cos x times cos x. That is what it means, right? That is what it means. Now, this thing here is different. Remember what order of operation says. What this is saying is that let's say x was equal to 4, and I just made up 4 just top of my head. What if x is equal to 4? Then let me show what the difference is. If I'm doing cos squared x, then I'm going to do this. I'm going to find the cos of 4, and then I take that answer, I'm going to square it. Okay? Take your calculators, tell me what that is, please. Find the cos of 4. Make sure in radians, by the way. Find the cos of 4, and then square your answer at the end. I'm going to grab my calculator in the meantime and do the same thing. Find the cosine of 4, right? Get your answer and then square your answer. And let me hear what you get when you do that. Please, everybody. Give me to maybe, what, 2 decimal places. What are you getting when you round that to 2 decimal places? The cosine of 4 all squared in radians. Make sure you're in radians. For this part of the course, you want to make sure your calculus is in radians. All right, Kristen, everybody else, what did you get when you did that? I just worked it out for myself. What did you get? 0.43, good. Now here's the other one. If I took the cosine of x squared, then what I'm saying is the cosine of 4 squared is what I'm saying this time. So let's see what that is. So hit the cosine button, then hit 4, square it, and let's see if the answer is the same. Okay, getting a complete different answer. Thank you, Jeremy. Now we're getting minus 0.96, rounded. Okay, so do you see the difference there now, Kristen, between the two things? In one case, you're squaring the number first and then taking the cosine. In the other case, you're taking the cosine first and then squaring your answer. Do you see that difference there, Kristen? Okay, good. And thank you very much for the question. Okay, let me backtrack now. So we've got a couple of things that we figured out. Let me go back and show you what we figured out. We figured out that the cosine of x plus y is equal to this identity. The cosine of x minus y is equal to this identity. We also figured out that the sine of x plus y is equal to this identity, sine of x minus y is equal to this identity. And that we have some double angle formulas as well. The cosine of 2x is cos squared x minus sine squared x. The sine of 2x is 2 sine x cos x. All right? Again, don't memorize any of these. I will give most of them to you. I may ask you to derive 1 or 2 of them, but yeah, you can see how to derive from what we just did. Let's put this to use. Let me delete this page. We're going to use these relationships, these identities, to get exact answers for some angles, for the cosine, the sine, and so on of some angles. So pay close attention. And I start off with the cosine of 13 pi over 12. So let me first of all move these two out of the way. All right, we'll get back to them shortly. Okay. Can we use that to come up with an exact value for something like the cosine of 13 pi over 12? That's the question we're going to try to answer. So exact value means I don't want a decimal. I want something that's exact. If there is any square roots, leave them as square roots, right? So I'm thinking, okay, how can I split up 13 pi over 12 so that it is either a sum or a difference? Not only that, that sum or that difference needs to be one of those special angles that we talked about 2 classes ago. All right, so let me just think for a second now. 13 pi over 12, 13 pi over 12. Well, there are a couple of ways I could split that up. I could write it as maybe 1 plus 12, but that doesn't help me because 1 over 12 is not a special angle. 12 over 12 is not a special angle. So I'm going to say, nah, that doesn't help me very much. How about if I said 2 plus 11? Well, 2 over 12, yeah, that would work. But 11 over 12, that doesn't help me very much. So I'm going to erase that as well. How about if we tried maybe 3 plus 10? So both of these are pi's over 12. Well, hold on. This might help me out because, and that's 13. And we all agree on that that's 13. That's the same thing as 13 pi over 12. This one works out to be pi over 4. That's one of those special angles. And this one works out to be 5 pi over 6. That's another special angle, right? We know how to do that. That was in that little online quiz thing that we did the other day. If we got that, we could have found out what that was, right? In using the special angles. Are there other ways we could get that? Okay, so that's one. So I'm going to say that this works. This will work. What if I tried 9 plus 4? Wait, so 9 over 12 and 4 over 12. Well, if I reduce this down, I'm going to get 3 over 4. So that works. And then I'm going to get, and these are both pi's, by the way. And I'm also going to get 1 over 3. So 1 pi over 3. Both of these are special angles as well. So as long as when you reduce it down, you get a special angle. That's what we're trying to do now. Okay, that's the real goal. Are there other ways you could do it? Let's see. Could we do it as a difference? So this is another way we could have done it. Let me just acknowledge this first of all. These would have worked, right? Are there others? Yeah, there are probably others. What about if it was a difference? Or 3, 4, 5, and 6? Yeah, I think you're on. I think you're on the right track now. What is a difference? I could get 13 by taking maybe 14 minus 1. I put those both over 12, right? That will give me 13 over 12. But then if I reduce those down, that doesn't help me out very much, right? I mean, I'm going to get 7 over 6, and that's a special angle. But 1 over 12, that's not a special angle. How about if I did, I don't know, let's see, maybe 15 minus 2? Let's see if we reduce that down, what that's going to give us. Well, 15 over 12, oh, hold on. That might be something there. 3 goes into 15 5 times. 3 goes into 12 4 times. So 5 pi over 4, that works. Plus or minus 1 pi over 6. That seems to work as well. So these should also work. Did I do that right? 3 into 15 is 5, 3 into 12. So yeah, 5 pi over 4 will work, and 1. So this also works. So these two will work as well. So this one will not, right? But this one will. So I can actually choose any one of these, and maybe there are more, right? I just came up with 3 of them that will actually work. I could do 3 plus 10. I could do 9 plus 4, or I could do 15 minus 2. They all give me 13 over 12. Right? So let me take a quick vote. Which one do you, and by the way, we're all going to get the same answer. So let me take a quick vote on this. Let's give these all letters. A, B, or C. Who wants to vote for, put your choice in there, please. Okay, got a B, I got an A, I got another B, got another A, I got some more B's, I got some A's. All right, let's see. Nobody likes C. I don't know why not. What's wrong with C? C's like a lonely little person sitting in the corner over there. Let me do a quick count here. So let me see. B's got 1, 2, 3, 4, 5, 6. The A's got another B. I think the B's have it. I think the B's have it. 1, 2. Yeah, I'm going to say the B's got this one. No, the fact is we're voting on it. The truth is that it doesn't matter which one you choose. The answer is going to be the same. All right, so we're going to go with the B's then. So the B one says 9 over 12 plus 4 over 12 is the same thing as 3 pi over 4 plus pi over 3. All right, you can confirm that for yourself. 9 over 12 is 3 over 4. 4 over 12 is 1 over 3. So I'm going to rewrite my original question. Instead of saying the cosine, I don't know why I'm at red. Instead of saying the cosine of 13, oh, sorry. Let me erase that. Instead of saying the cosine of 13 pi over 2, oh, you know what I just realized? We're running way past the break. Sorry, folks, I don't want to take away your break from you. It's 11:16. Let me give you your 5 minutes to kind of recover from that, and we come back at 11:21.
And here's a 7 pi over 12. No, there are some approaches we could take to do this. Do we do this with a sum? Do we do this with a difference? Which sum, which difference is going to work? So let me try thinking of some sums that might work. So let's say we could start off with, and by the way, I don't have my stylus per se. This is now a laptop that wasn't built for a stylus, so my writing is going to be worse than it. It's usually bad. It's going to be worse than that now. So I could try doing 1 over 12 plus 6 over 12. That's one way to do it. When I'm looking at 1 over 12, 1 pi over 12 is not a special angle. 6 over 12 is. That's a special angle, so that would have worked. But this is not going to work because I'm not going to be able to get a special angle out of 1 over 12. What if I did 2 plus 5? All right? 2 over 12 and 5 over 12. Well, that's great for the 2 over 12 because that's pi over 6, but 5 over 12, that's nothing. I don't have anything with that. So that's not going to work as well. But how about if I did 3 plus 4? That's going to give me 7 pi over 12. And 3 over 12, well, that reduces down. So does 4 over 12. That also reduces down. So this one works out to be pi over 4. And this one works out to be pi over 3. Oh, so that works fine. That's going to give me back my 7 pi over 12. So I'm going to go ahead now, and I'm going to say that the cosine of 7 pi over 12 is the same thing as the cosine of pi over 4 plus pi over 3. That's an odd looking 3. Let's see if we can tidy that up. Plus pi over 3. That's equivalent. These two things, right, this and this, they're both the same, right? 7 pi over 12 is pi over 4 plus pi over 3. So now I need to go back and see which one of these things I can use, right? Am I going to use the sine of x plus y, the sine of x minus y, the cosine of x plus y, the cosine of x minus y? Which of these makes the most sense for us to use at this point? What do you say, folks? Which one of them? Sine of x plus y, sine of x minus y, cosine of x plus y, cosine of x minus y. Which of them makes the most sense if we're going to be looking at the cosine of pi over 4 plus pi over 3? Which of them makes most sense? Which one should I copy over to this page so we can use it? Is it only Harish who is following along here, folks? Yes, Harish is right. But does that make sense to everybody? So it's the same as the last time. Yes, same as the last time. So I'm going to go ahead and I'm going to go over there and copy again the same thing, clone the same cosine of x plus y, or copy it anyway, and copy it onto this page. Bring that down here, and let's get ready to use it again. Now here's a great thing that we're looking at. All of these angles are in the same quadrant, pi over 4 and pi over 3. What quadrant am I talking about? Okay, Elizabeth, what quadrant am I talking about this time? Both of these angles, the pi over 4 and the pi over 3, are both in quadrant, yes, no, yes, Emily, good, quadrant 1. That makes it so much easier for us. It means that everything is going to be positive. So what is this equal to? Well, according to what this says, it's equal to the cosine of pi over 4 multiplied by the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. Again, I'm just following what this identity says. Okay. Cosine of pi over 4, again, that's another one that I know is 1 over root 2. I do know that one. Times the cosine of pi over 3. Well, we just did that. I was told by Emily back then it was 1 over 2, so it's not going to change. Minus the sine of pi over 4 is also 1 over root 2. And because the cosine of pi over 3 was 1 over root 2, I know that the sine of pi over 3 is root 3 over 2. Okay, so this one works out to be 1 times 1, which is 1 over 2 root 2, minus 1 times root 3 is root 3 over 2 root 2. So that means that my final answer is just simply 1 minus root 3 over 2 root 2. Again, that is in exact form, which is what I was required to do. I wanted an exact form answer. And this time, again, I do not want to see what the calculator is going to spit out, because calculators will give you answers without you even thinking about it. This is the answer that I'm going to be seeing. If I'm going to give you a mark for this and mark it right, I'm going to be looking for this answer. Okay, so you need to understand how to do it for yourself. Not what the calculator does, but what you can do for yourself. Okay, let's try one more as a class. I had another one here which is buried somewhere behind all of this stuff. Where is it? I might just have to make one up. So there's a cosine of that. The tan of this thing, we're going to talk about that in a minute. But where's the other one? There was a third one or a fourth one, which I cannot find anywhere. Maybe behind one of these things right here. Actually, I know where I can find it. I can look at, actually, I'm just going to make one up. I'm just going to make one up. Let us say, we go to a brand new page with this one. Let's say it was the sine of 11 pi over 12. Let's say that's the one that I wanted to do, right? Can anybody suggest a way that I might be able to write that as either a sum or difference of two other angles without me going through all the different permutations? There is more than one, or there are more than one, right? So can anybody come up with one on your own this time for the sine of 11 pi over 12? Is there a way to get that? So Rachel is thinking 3 over 12 plus 8 over 12. And I agree. So 3 pi over 12 plus 8 pi over 12, right? We can all confirm that those actually work out to be. Jeremiah is also saying 3 over 4 plus 1 over 6. 8 over 12, are you reducing down? Oh, you're doing it a different way then, I'm assuming. Oh, you said, yeah, you must be doing it a different way for you to get that. Let me just think now. There's 3 over 4. I'm just double checking it with my over 1 over 6. I agree with you on that one. Yes, I do agree with that. That also works. And 9 plus 2 also works. Can it be done as a difference, by the way? So Rachel's answer, I completely agree with. Jeremiah's answer, I agree with. In fact, Jeremy came up with 2 different options. Oh, no, that you're telling me how you got that number, 9 plus 2. Is there a way we could do it as a difference? Is there any difference that would have made that work? Anybody think of a way to do it as a difference instead of as a sum? Think about that. Right? So doing it as a sum right now, but is there a way to do it as a difference? Can you think of 2 things that we can subtract that will give you 11 over 12? 14 minus 3 absolutely does work. 14 over 12 would reduce down. And so 7 over 6 minus 1 over 4. Yes, that actually does work. Is everybody following this here? Does this all make sense? And again, does it matter which one of these combinations we use? No, it does not matter which one you use because you're still going to end up with the same answer. So we'll go with the one that Rachel gave us the first time, which was the 3 pi plus the 8 pi, and that gives us 11 pi over 12. So we're going to go with that. And that, of course, reduces down to pi over 4 plus, if you did 4 into 8, which is 2, and 4 into 12, which is 3, so 2 pi over 3. All right, so pi over 4 plus 2 pi over 3. All right, let me pause and see if everybody is okay with that so far. All right, so pi over 4 plus 2 pi over 3, all I'm doing is reducing down those 2 things. So instead of saying the sine of 11 pi over 12, I'm going to say that the sine, oh, my writing is getting worse and worse, of 11 pi over 12 is the same thing as the sine of pi over 4 plus 2 pi over 3. Okay? I'm going to say that those 2 things are identical. The left side is equal to the right side. I've just simply took the 11 pi over 12 and split it into 2 parts. So I'm going to go ahead and get the sine of, and by the way, which of the, let me go back to the previous page. Which of these 4 things do you think I should be using now to answer my question? All right, I have sine of x plus y, sine of x minus y, cosine of x plus y, cosine of x minus y, and Axa and Karis are both saying the same thing. It is the sine of x plus y. So let me clone that or copy that onto my next page. Okay. And by the way, this device is far more responsive than the last one. I don't know why the second one. I just had a Windows update, and I wanted the Windows update has not has sort of slowed me down. I mean, I'm a little scared now as to why it was being so laggy. All right, anyway, so sine of x plus y is equal to all of this stuff here. So let's go ahead and apply it. So that's equal to, in this case, the sine of pi over 4 times the cosine of 2 pi over 3. Again, just following this thing, plus the cosine of pi over 4 times the sine of 2 pi over 3. Okay, we've got to get our quadrants right now. Where is pi over 4? Where is 2 pi? Let's start with pi over 4. What quadrant is pi over 4 in? Okay, Joel says 1. Jeremiah says 1. Karis says 1. Anybody else want to go sign on with 1? Are we all sure about pi over 4 being in quadrant 1? Does that make sense to everybody? Okay, I only got 3 people weighing in on that. Joel, Jeremiah, okay, great. Okay, perfect. How about a 2 pi over 3? Where do you think 2 pi over 3 is? Okay, that is in quadrant 2. All right, good. So let's see if we can put this together now. First quadrant is pi over 4. So I'm going to say that's 1 over root 2. That's one of the ones I do know. Now the cosine of 2 pi over 3 is the same thing as the cosine of pi over 3. That's the related acute angle. But it's in the second quadrant, so whatever we get should be negative. And I believe when I asked about pi over 3 before, somebody told me that it was 1 over 2. So I'm going to say this is negative 1 over 2. That's what I'm going to say. All right? And you can correct me if I'm wrong. So the cosine of 2 pi over 3 should be minus 1 over 2. Before you stop sharing your screen, do you mind showing me the angle formula in the previous page? Sure. So this is the page you're talking about. Jeremy? Is this the page you're looking for, Jeremy? Okay. And you can see all 4. Again, I am recording it, so you should have the benefit of the recording later on. Okay, so let me go back now. You're welcome. I'm going to go back now. Let's keep going here. So what I have so far is that the sine of pi over 4 is 1 over root 2. The cosine of 2 pi over 3. So I'm looking for the cosine of pi over 3, which I was told, I believe it was Emily who told me this earlier on, was 1 over 2. But I'm making it negative because you all told me that 2 pi over 3 was in the second quadrant. Okay? Plus, the cosine of pi over 4 is again 1 over root 2. One of the few that I know. I do know that the cosine and sine of pi over 4 is always 1 over root 2. Then the sine of 2 pi over 3 is the same thing as the sine of pi over 3, which should be root 3 over 2. And it's not plus, it's times. Let me erase this actually. Let me erase all of that. So it's times the hall pass, Nicholas says. Okay, Nicholas, 11:55, so take you back by midday. So this is going to be root 3 over 2. All right. And I'm going to see if I can put this together now. So that should be equal to minus 1 over 2 root 2 plus root 3 over 2 root 2. And then when I put these two together, that should be minus 1 plus root 3 over 2 root 2. Okay, obviously you can write the other way around. You can say root 3 minus 1 over 2 root 2. That would be the same thing. Okay? All right. Is everybody on board with that so far? Are we good with that so far? Let me do another quick check-in here to make sure that everybody's following along. Axa, how about you? Emily, how about you? Axa, just checking to see if you're following along, and Emily as well. Okay, great. All right, let's go back to the previous page again and see what else we have over there. We have this tan of pi over 12. Okay. I don't see the other. I know I had another one in there somewhere, but I can't find it. So we'll do that one. So let me take you back now. Let me copy this onto a new page. And let's talk about how we're going to do this. So let's copy that. Now, is this even possible? Tan of pi over 12. Is there a way that I can add two angles together to get this? The reason that we're saying that is because when we looked at all of these functions before, all of these identities before, sine, cosine, there was no mention of tan anywhere. There is no tan. I mean, there is, let me just be clear, there is a compound angle formula for tan, but we haven't discussed it. We haven't talked about it. So I'm saying, what if I gave you something like this, but I just gave you the formulas for cosine and sine? What are you supposed to do? Well, Jeremy is on the right track, right? The fact is that tan of pi over 12, and this is something we're going to be doing when we start looking at trig identities later on, is the equivalent of taking the sine of pi over 12. This is really horrible, folks. I'm going to apologize for this horrible writing. Over the cosine of pi over 12. It turns out that anything that I'm taking the tan of, I can also find the cosine of that thing divided by the, that is a cosine first, the sine of that thing divided by the cosine of that thing. That would give me the same thing as tan, FYI. So if we can get the sine of pi over 12, and then if we could get the cosine of pi over 12, and then we divided those two things together, we would end up with the tan of pi over 12. So we're going to tackle those two things separately. That's what we're going to do. So the first thing is the pi over 12, to get the sine of pi over 12. Let's talk about that. Now, so far, we've been adding numbers together and sometimes subtracting numbers from each other to find a way to separate the angle that we're talking about. Is there any way we can add two angles together to get the pi over 12? Is that even possible? Think about that. What angles? Jeremy says no. What do other people think? Can I add any two angles together and get that 1 pi over 12? Well, unless you're going to be talking about maybe 0.5 and a 0.5, but we don't have, that's not going to give us any special angles. So I have to answer the question and say, no, we can't add two angles together to get pi over 12. But can we subtract two angles from each other to get that pi over 12? That's what I want to throw to the class now. Think of any two angles that I could subtract from each other, and the two things that I get when I reduce them down would become special angles so that we could use those special angles. Okay, so Rachel is saying 4 minus 3, right? And Harish is agreeing and Emily is agreeing. And I completely agree. So what we're saying is, to get that 1 over 12, we could say 4 pi over 12 minus 3 pi over 12. I think we can all agree that that gives us 1. 4 minus 3 is in fact 1. Are there other ways we could do it? Perhaps. But we hit this one straight up the first time. Let's just go with it. Now, if we reduce this down, 4 pi over 12 would be pi over 3. And 3 pi over 12 would be pi over 4. Right? That's just reducing it down to its smallest terms. Okay. So far, so good. Well, I like to do my little check-in from time to time. Jeremy, how about you? Does that make sense so far? Kayla, how about you? So Jeremy and Kayla, can I ask you both to check in for me, please? Jeremy says yes. How about Kayla? Kayla, are you with us? Where's Kayla? Where is Kayla? Okay, Kayla. Good. Okay. No. And I'm assuming you're both, apart from checking in, that you're following along with what we're doing. All right. So let's go back to the page that has all the formulas on it and tell me which of these do I now need. In fact, let me number them for you. So let's call this 1, 2, 3, and 4. Which of those formulas do you think we need to get the sine of the 11 pi over, sorry, the 3 pi over, the 3, sorry, pi over 12. So equation number 2. So we'll do exactly that. I'm going to copy that one now onto my second page. Because I don't expect you to memorize them. I just expect you to know how to use them. Here we go. Let's paste this in. Put that down there. And now we're going to use it. So first of all, I'm going to say that the sine of pi over 12 is x minus y. So the sine of, this is my x, and this is my y. So it's the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. Okay? Now, pi over 3 and pi over 4. Let's start with pi over 3. What quadrant is that in again? We've dealt with pi over 3 before. What quadrant is pi over 3 in again? It's in quadrant 1, Joel says. How about everybody else? All right, Joel says quadrant 1. Jeremy says quadrant 1. Anybody else want to give me an answer that they think that might work? Okay, good. What about pi over 4 though? Where is that one? Where is pi over 4? Okay, also in quadrant 1. That makes our job a lot easier. A lot easier. So let's see if we can do this now. Let's see if we can do this. The sine of pi over 3, well, I believe, and you can double check me on this one, since in the first quadrant everything is going to be positive here, I believe it's root 3 over 2. The cosine of pi over 4, I'm pretty sure is 1 over root 2, minus cosine of, if this first one, if I got this right, then this second one is going to be 1 over 2 times 1 over root 2. Okay, so this looks like root 3 over 2 root 2 minus 1 over 2 root 2, right? Which means that's all equal to root 3 minus 1 over 2 root 2. So far, so good, folks. All right. One more little quick check-in here before I go any further. Okay, so Nicholas, let me know that you're there. And Rachel, let me know that you're there. Nicholas and Rachel. Where's Rachel? Okay, perfect. All right. Okay, so that answers the question as to what is the sine of pi over 12. Okay, that's good. But what we said was we also have to find the cosine of pi over 12. And we can use the same difference, except this time we're not going to use this formula. We're going to use the one for cosine. So let me go ahead and copy that, this one right here. We're going to go through the same process. So copy that into the same page. Let's extend the page. Somewhere down here would be good. Now we're going to go with cosine, right? Same thing, same x and same y. So that would mean then that should be equal to the cosine of the x, remember, was the, I'll just remind you, the x was the pi over 3. So the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. Okay, let me throw it over to the class. Remind me now, what's the cosine of pi over 3? Anybody? What's the cosine of pi over 3? By the way, somebody left a few minutes ago for a took a hall pass. Let me just see, that would have been like from quite a while back. I don't remember who that was now. That was Nicholas. Okay, Nicholas is back. Yeah, I know that because I just called out Nicholas a while ago. All right. So cosine of pi over 3. What is that again? What's the cosine of pi over 3? Anybody? 1 over 2. Okay. Okay, that one, hopefully everybody knows now that that's 1 over root 2. Plus, the sine of pi over 3 would be the opposite of this one. So that's going to be root 3 over 2. And this is also 1 over 2. Oh, 1 over root 2, sorry. So that is equal to 1 times 1 is 1 over 2 root 2 and root 3 over 2 root 2. So it looks like this works out to be 1 plus root 3 over 2 root 2. So here's what we're saying. Jeremy was right about something. He said, let me take you back. He said that if we took the sine of pi over 12 over the cosine of pi over 12, that would be the same thing as the tan of pi over 12. So let's put that all together then. Let's see if we can put this all together. The tan of pi over 12, I'm going to be a little clumsy here, is equal to what we said was the sine of pi over 12. The sine of pi over 12 was root 3 minus 1 over 2 root 2. So root 3 minus 1 over 2 root 2. So that's on top of the fraction. On the bottom of the fraction is what I'm pointing to here, because we just had that, which is the 1 plus root 3 over 2 root 2. Now, how do I divide a fraction by a fraction? So this fraction on top is being divided by this fraction on the bottom. How do I do that exactly? How do I divide two fractions? Think back to elementary school now, right? So on top I have root 3 minus 1 over 2 root 2. On the bottom I have 1 plus root 3 over 2 root 2. How do I multiply by the reciprocal, Noah says? Perfect. So we'll do exactly that. So multiply the numerator, by the way, by the reciprocal. So we'll do exactly that. So on top we have root 3 minus 1 over 2 root 2 multiplied by 2 root 2 over 1 plus root 3. That's what this is equal to. Does anybody notice anything here that might be of some help in trying to wrestle this thing to the ground? Try to simplify this somehow? Is there anything that anybody notices about this? It says root 3 minus 1 over 2 root 2 times 2 root 2 over 1 plus root 3. We can, in fact, reduce out the 2 root 2's. Absolutely. So this cancels with that. And here's what we're left with. We just sort of do this, get that out of the way. So that's equal to, I'm trying to get that back to black. Come on, black. Okay, that's equal to root 3 minus 1 over 1 plus root 3. Now, I'm perfectly fine with you keeping the answer like that, because what it tells me is that you actually did this and didn't just put it into a calculator. The truth is that this can be further simplified, just saying, because you can do something called rationalize the denominator. But I'm going to be consistent and say that I want you to leave the answer exactly like that. That's the way I want this answer to be, right? I don't want you to try to rationalize the denominator. If you put the tan of pi over 12 in the calculator, it's not going to give you this. It's going to give you an a rationalized form. But what I want you to give me, if I give you a question like this, is this one here. Okay? Now, I wonder if I threw something out to the class and said, I want you to find this inexact form, the sine or cosine of this angle, whether you could do it. That's what I'm wondering, right? And I'm going to challenge you right now to see if you can actually do that. Is everybody ready for that challenge? Or do you think you're ready for that challenge? Right? Is everybody ready to try one of these things on your own? Nobody doesn't think they're ready for the challenge. I mean, the challenge is coming anyway, so whether you're quite ready for it or not, it's a coming. Okay? So here it comes, folks. I'm going to write a question on the smart board and ask you to try to do this. Figure out a way to do this one on your own. Let me get a brand new page here. Right? So I won't make it a tan question because tan means we're going to have to do the sine and the cosine. I want you to find the cosine of, without using your calculator now, right? I know you can find a way to do this on your calculator, of 19 pi over 12. Okay, let me tidy that up. Let me tidy that up. 19 pi over 12. Try to figure out a way that you can do that. Angle x is in the second quadrant. The sine of x is 5 over 13. Determine an exact value for the cosine of x. And then from that, determine an exact value for both the cosine of 2x and the sine of 2x. So first things first. If it's in the second quadrant, I'm going to draw a little chart here, right? And in that second quadrant, if the sine is 5 over 13, let's create a little triangle. Again, always measure your angle from the closest x-axis. So that would be this one down here. And I put a little dotted line there, a little dotted line here. If it says sine of this angle, let's call this angle here theta. Right? The sine of that angle, if that's 5 over 13, that means that this is 5 and this is 13. Opposite over hypotenuse. That's not even close to being 13, Mr. Kamak. Let's try that again. Here's my eraser. Okay, so this is 13. Why do I say that? Because looking at this angle that I'm pointing to right here, it's opposite over hypotenuse. That's what sine is, opposite over hypotenuse. Now, for us to get the cosine, we need the adjacent side. So we need this side right here. In fact, that's the same as the x coordinate, if you think about it, because I'm moving along the x line. Well, I don't have that side. So what am I supposed to do now if I don't have that side? Can anybody help me out with that? They didn't give us that side. We're supposed to find the cosine, but they didn't give us that adjacent side. So what am I supposed to do with that? Pythagorean theorem. Thank you very much. So I'm going to say that x squared plus 5 squared is equal to 13 squared. That's what the Pythagorean theorem says. The two shortest sides, when you square them out together, you get the longest side, the hypotenuse. So that means that x squared is therefore equal to 13 squared minus 5 squared. Just doing the algebra on that. So x squared is equal to 169 minus 25, which is 144. That means that x is 12. That's what it means. That's what x is. So now I can answer the question. Let me erase this right here. Now I can answer the question about the cosine of x. The cosine of, or let's say theta, or x, okay. I use x for something else, but anyway. The cosine of this angle is now equal to the adjacent side, which is here, which we just said is 12, over the hypotenuse, which is 13. So, that's a weird looking 3. Hang on, I spent half the time apologizing for my bad writing. 12 over 13. So if the sine of x is 5 over 13, as I'm pointing to right here, then the cosine of x is equal to 12 over 13 by just using Pythagoras to find what the adjacent side is. Okay? Let's use that now to find the cosine of 2x and the sine of 2x. Well, I'm going to remind you, I'm going to take you back a couple of slides here. One of the things that we worked out a few minutes ago was this sine of 2x, which we said was 2 sine x cos x. And the cosine of 2x we said was cos squared x minus sine squared x. Let's see if we can use that to answer this question. So the cosine of 2x, I'm just going to write down what the identity says, is equal to cos squared x minus sine squared x. That's what the cos of 2x is, right? It's the, hold on one second. That's what the cos of 2x is. This is the identity for it. So that means that I should be able to write this now for the cos of 2x as the cos of x squared, and the cos of x is this thing right here. It's 12 over 13. So it's equal to 12 over 13 squared, because that's what the cos of x is, 12 over 13, minus the sine of x, and the sine of x was given to us as being 5 over 13, minus 5 over 13, also squared. Okay, I'm just following what this says, that the cos of 2x, they asked us for the cos of 2x. That's what the question says, the cos of 2x right there. Well, the cos of 2x is cos squared x minus sine squared x. I have the cos of x, it's this thing right here. I have the sine of x, it's this thing right here. So I'm going to take the cos of x and square it, the sine of x and square it, and I'm going to finish the math now. So that means that's 144 over 169. Again, I'm not using a calculator, you can double check me on that, minus 25 over 169. They both have the same denominator, so that would be 119 over 169. That's what the cos of 2x is, to answer that question, right? It's the square of the cos minus the square of the sine. I did the math on that, and it works out to be this. Again, double check me on that, right? I'm doing this mentally now. We have the formula for like cosine on, yes, Jeremy, I will give that to you. You don't have to memorize it. I'm not into memorization. I don't encourage students to commit things to memory. I want to encourage you to understand process, right? And how do I get there? So if I don't have to cram things into my brain cells, and in my case, you know, I just don't want to be filling up my head with a bunch of formulas, right? I want to understand how to get there rather than, you know, remembering things just by rote. So that's my answer for the cosine of 2x. For the sine of 2x, according to the formula, I write the formula down again. It's 2 sine x times cos x. So that would mean that in this case, it's 2 times the sine of x was given to us right at the beginning of the question, 5 over 13. 2 times 5 over 13 times the cos of x, which we worked out to be 12 over 13. So that would mean that my answer, 2 times 5 is 10, times 12 is 120, all done in my head, folks, over 169. And that's my answer for the sine of 2x. It's 120 over 169. Okay, in the 5 minutes that we have, I'm going to do one last question with you, then I'm going to tell you goodbye. You're going to go have your lunch. All right? Last question. Oh, no, let me just pause for a second. Is anybody who isn't sure about the steps I just took to get to those two answers? So the cosine of 2x is 119 over 169, and the sine of 2x is 120 over 169. Just using the identities, right? First of all, figuring out, they gave us the sine, they didn't give us the cosine, so we found the cosine first. We just plugged them into the formulas or into the identities and got our answer. Okay, one last thing, then we're done. Angle X and Y are located in the first quadrant. So these are both first quadrant angles, such that the sine of X is 4 over 5, and the cosine of Y is 7 over 25. It's a very similar question. Find the exact value for the cosine of X, the exact value for the sine of Y, then find an exact value for the sine of X plus Y. First things first. If the sine of X, whatever X is equal to 4 over 5, let's consider what that means in terms of an angle in the first quadrant, right there. Again, I'm going to drop a little triangle there. Again, we're going to use this angle that measures to the closest x-axis, right? So if the sine of this angle is 4 over 5, then this is 4, and this is 5. How long is this line down here along the x-axis? Can anybody tell me what that is without me having to do a lot of work? What's the length of this line down here? So sine is opposite over hypotenuse. So this is 4 over 5. Opposite is 4, hypotenuse is 5. That's what the sine of x is, 4 over 5. Who knows what the length of this side down here is? All right, Harish says 3. Can we all agree on 3? Because it is 3. I'm trying to rush along a little bit here. Can we all agree on 3 for that? Does 3 make sense just using Pythagoras? Right? I'm going to put 3 in down here, which means that the cosine of x, cosine is adjacent over hypotenuse, is equal to 3 over 5. Okay? All right. So they asked us for the cosine of x. We found the cosine of x. It's this. They're asking us for the sine of y. The cosine of y is 7 over 25. So let me put that in another little first quadrant triangle. Now, if the cosine is 7 over 25, it means that this side is 7 and this side is 25, right? Because that's adjacent over hypotenuse. That's supposed to be a dotted line. Never mind, it doesn't look like one. It's a dotted line, right? Can anybody tell me what the size of this side is over here? That's like my y quadrant over here, because that's along the y line. Can anybody tell me what the length of this line is over here? Right? Quickly tell me what that is. Okay, so I'm getting 24, and I agree that that's 24. So very quickly, the sine of y is equal to 24 over 25. Right? It's equal to the opposite side, which you said was 24, over 25, which is the hypotenuse. Okay? So we have the cosine of x and we have the sine of y. They asked us for that. They asked us for the cosine of x, asked us for the sine of y. We got them both. Now, an exact value for the sine of x plus y would be as follows in like 20 seconds. The sine of x plus y, we have to go back and find the formula for sine of x plus y. I'm going to go back and show it to you because I don't remember it. Again, I'm not asking you to commit it to memory, and I don't remember it either. Oh, here it is. I just passed it. Here's the sine of x plus y right here. Ah, geez. I'm trying to get this thing to cooperate with me. It's not. All right. I guess it's trying to tell me that I should shut things down and wait until tomorrow. All right. So what I do tomorrow, I'll just finish up this question. I'm going to put this sine of x plus y, copy it onto that last page that we're working on, and just finish it up. Right? Just finish it up. So if you all could remind me that I haven't quite finished this question yet. Oh, here it is. Here it is, right down here. Huh. Okay, anyway, we're run out of time. It's 12:35 already. I would just put in all the stuff that we have. The sine of x is right there. The cosine of y is right there. Plus the cosine of x right there. Sine of y right there. Just fill them into this and then just tidy it up and you'd have your answer. I may not even have to finish this up tomorrow. Okay, folks, you've had a nice long stretch. It's 12:35. It's time for lunch. I will see you all tomorrow. Thank you very much. You have a good day as well. Bye-bye now.